Okay, so we have some rules for square roots. The product rule. So if A and B represent non-negative real numbers, now that's important, they're non-negative, okay, then the square root of AB equals the square root of A times the square root of B. And you can go the other way. You can say the square root of A times the square root of B equals the square root of AB. Okay, so it works both ways. So you might remember we kind of used this already. We said 64. We said, well, we could think of that as, 4 times 4 times 4. We use twos, but if you think about it, 2 times 2 is 4, right? Okay. So you could say that, and then you could split each of those up. What's the square root of 4? What's the square root of 4? What's the square root of 4? And then you would get 2 times 2 times 2. So you'd have to know the square root of 4, but, that's kind of the idea we were using. Okay, so let's look at another example here real quick. The square root of 12. So you say, well, I don't know what the square root of 12 is. It's going to be some, irrational number. I can put it in a calculator. But let's say I don't want to write a decimal approximation. I can think of 12 as 4 times 3. Well, then I can split it up into the square root of 4 times the square root of 3. The square root of 4, that I know, is 2. Now the square root of 3, it's an irrational number. I can write it just as the square root of 3. This is considered an exact answer. Call it an exact answer. It's not a decimal approximation. So sometimes we want the exact answers, especially in math. We do that a lot. Okay. Sometimes we want a decimal approximation. All right, so let's look at some examples here. Okay, so let's look at this one, A. It's the square root of 500. So we might want to think of that as 5 times 100. And now, why do we want to think of that? Why don't we go 50 times 10? Well, we're looking for something we know the square root of. And we know the square root of 100, so we can split it up. And then we're going to put the radical part at the back. That is pretty much standard, to put the real, not the real part, the rational part in front of the radical. Okay, so we would write 10 times the square root of 5. Okay, now let's look at the next one. We have multiplication going on between these two square roots. I can't take the square root of 6, I can't take the square root of 3, but I can put them together, okay? So I can say, well, what's 6x times 3x? Okay, then I can say, well, that's 18x squared. So how does 18 split up? Well, I could do two things here. I could split those up, but 18 is 9 times 2, right? So I can take the square root of 9. Now, if I were writing this all out, I could write it like this. Do we know what the square root of x squared is? We're assuming x is positive, and so we're just going to say that that is x, okay? Actually, they could write the absolute value of x on that one, right? Okay, so sometimes they do that. Now, how are you going to write it? They usually would write 3. Our old book used to put the absolute value. I don't remember if this book does. I'll have to look that up. At some point, they usually say, well, just assume the variables are positive. But I'm going to assume they want the absolute value here. And then the radical is at the back. I don't know the square root of 2. All right. So what if you make a mistake? Okay, so let's say you have the square root of 72. And you're like, okay, great, I can use the rule. I know 72 is 8 times 9. So I'm going to say it's the square root of 8 times the square root of 9. And then you're like, oh, good, I know the square root of 9. That's 3. 3 times the square root of 8, and that's going to get marked wrong, okay? So the problem is 8 breaks down still, okay? And so you have to think of 8 as 4 times 2. See, it could go further. And then what's the square root of 4? I'll write it all out here. Then the square root of 4 is 2, and so you'd get 6 times the square root of 2, and that would be the answer. Now, way back up here when we had the 72, you might have thought, hey, that's the square root of 36 times 2. And then it would have saved you a little bit of work because you would have had it, right off the bat. The square root of 36 is 6, and then the square root of 2 is the square root of 2. But all is not lost. You just have to check your radical, your square root, the part underneath, and see if it can break down more. Okay, so they did not use the absolute value. They just have 3, I looked it up, 3x square root 2. And their reasoning is that x had to be greater than or equal to 0. Now, the reasoning on that comes from the beginning. You'd have to have that be the 6x be positive, and 6 is already positive, so x has to be positive. And the same thing over here. So that's how they know x is greater than or equal to 0. Otherwise, you couldn't take the square root of it the way we did. You couldn't do that problem that way. Okay.